Good morning, students. Today we will continue with our chapter number 2, Chemical Changes and Reaction. Today we will study about the types of chemical reactions. There are 4 types of chemical reactions: direct combination or synthesis, decomposition, displacement, and double decomposition. We will study about them in detail one by one. So first, the direct combination or synthesis. A reaction in which 2 or more substances combine together to form a single substance is called a combination reaction or synthesis. Such as A plus B, they combine together to form AB as a product. In combination reactions, there are a variety of reactions like 2 elements combine to form a single compound. For example, carbon burns in oxygen to form a gaseous compound, carbon dioxide. C plus O2 gives CO2. The reaction between iron and sulfur to form iron sulfide, where iron and sulfur are elements and they form the compound iron sulfide. Heat is required to start the reaction, but once started, it continues exothermally. Various salts can be prepared by this method. For example, iron plus chlorine forms iron 3 chloride. Now, second type of combination reaction in which an element and a compound react together to form a compound. For example, carbon monoxide, a compound, burns in the presence of oxygen, which is an element, to form a single product, carbon dioxide. 2CO plus O2 gives 2CO2. Sulfur dioxide, which is a compound, reacts with oxygen to form sulfur trioxide. 2SO2 plus O2 gives 2SO3. Third type of combination reaction is in which 2 or more compounds, they form a new compound or product. For example, ammonia and hydrogen chloride, both compounds, they combine to form a new compound, ammonium chloride. NH3 plus HCl gives NH4Cl. When calcium oxide, also called quicklime, combines with water, a vigorous reaction takes place with the liberation of a large amount of heat. That is, this reaction is an exothermic reaction. Calcium hydroxide, CaOH2, which is also called slag lime, is formed. CaO plus H2O gives CaOH2. Slag lime is used for whitewashing. When a solution of slag lime is applied to the walls, calcium hydroxide reacts slowly with carbon dioxide present in the atmosphere to form a thin layer of calcium carbonate on the walls of the building. CaOH2 plus CO2 gives CaCO3 plus H2O. Layer of calcium carbonate formed gives a shiny finish. The reaction of photosynthesis is also a combination reaction in which small molecules of carbon dioxide and water, both of them are compounds, are used to make glucose. 6CO2 plus 6H2O in presence of sunlight and chlorophyll form C6H12O6 plus 6O2. How can we do simple experiments to show the direct combination reactions? We can take some black lead sulfide in a test tube and heat it. The black lead sulfide reacts with oxygen to form white lead sulfate. PbS plus 2O2 gives PbSO4. Hold a piece of magnesium ribbon over a flame. It burns with a white dazzling light, forming magnesium oxide. 2 Mg plus O2 gives 2 MgO. Second type of chemical reactions are the decomposition reaction. The reaction in which a compound splits into 2 or more simpler substances, elements or compounds is called the decomposition reaction. In a decomposition reaction, usually a single reactant decomposes without the presence of a second substance, and very often the action of heat is sufficient to cause a reaction to take place. So suppose AB is a compound, it decomposes to give the products C, D and so on. Decomposition is the breaking up of a compound either into elements or simpler compounds such that these products do not recombine to form the original compound. That means we will not get the reactant back again. Decomposition may occur in the presence of heat or light or by the passage of electric current. Heat, light and electricity are the different forms of energy which cause the breaking of the bonds in the molecule of reactants to yield the simpler products. In a decomposition reaction, again we have three types of reaction. First, in which a compound breaks up into two or more elements. That means the products forms are elements. For example, the compound mercuric oxide when heated decomposes to form two elements, mercury and oxygen. 2HgO on heating gives 2Hg plus O2. When silver chloride, white silver chloride is exposed to sunlight, it undergoes photochemical decomposition, forming the grey metal silver and greenish yellow gas chlorine. 2AgCl in presence of light gives 2Ag plus Cl2. When electric current is passed through the acidulated water, we have done in the last class also that water in which acid is present, that is called the acidulated water. The latter decomposes, that means the water decomposes into hydrogen and oxygen. 2H2O on passing the electric current forms 2H2 plus O2. Now the second type of decomposition reaction in which a compound breaks to form element and a compound. For example, the compound potassium nitrate on heating decomposes to produce a compound potassium nitrite and an element oxygen. 2KNO3 on heating forms 2KNO2 plus oxygen. Next type of decomposition reactions in which a compound breaks to form two or more compounds. For example, the compound calcium carbonate on strong heating decomposes to form two compounds, calcium oxide and carbon dioxide. CaCO3 on heating gives CaO plus CO2. Ferrous sulfate undergoes thermal decomposition to give ferric oxide, sulfur dioxide and sulfur trioxide. FeSO4 on heating gives Fe2O3 plus SO2 plus SO3. Ferrous sulfate crystals are actually ferrous sulfate heptahydrate FeSO4 into 7H2O. The 7H2O which is present in it is water of crystallization, which gives the crystals particular color. These crystals are green in color. On heating in the test tube, they change to white and then a brown solid is formed. The gas coming out is a mixture of sulfur dioxide and sulfur trioxide, having the suffocating and pungent smell of burning sulfur. A decomposition reaction that is brought about by heat without any recombination on cooling is known as thermal decomposition. Decomposition of compounds of metals by heat are based on their reactivity. Compounds of reactive metals are more stable, and as we move down in the reactivity series, the compounds decompose easily. The reactive metals are stable and so they do not decompose easily. The metal hydroxides of potassium and sodium, they are stable to heat and they do not decompose. The metal hydroxides of calcium, magnesium, aluminium, zinc, iron, lead and copper, they on heating decompose to form metal oxides and water vapor. Calcium hydroxide gives calcium oxide plus water. Zinc hydroxide gives zinc oxide plus water. Lead hydroxide gives lead oxide plus water. Copper hydroxide gives copper oxide plus water. mercury and silver, they yield the metal, oxygen and water vapor. For AgOH, that means silver hydroxide, gives silver plus oxygen plus water. The carbonates of potassium and sodium are stable to heat and soluble in water, that is, they do not decompose. The carbonates of calcium, magnesium, aluminium, zinc, iron, lead and copper, they decompose on heating with decreasing vigor to form metal oxides and carbon dioxide. For example, magnesium carbonate forms magnesium oxide and carbon dioxide. Zinc carbonate forms zinc oxide and carbon dioxide. Copper carbonate forms copper oxide and carbon dioxide. The carbonates of mercury and silver, they decompose on heating and form metal, oxygen and carbon dioxide. Ag2CO3, that is silver carbonate, forms silver, oxygen and carbon dioxide. The metal bicarbonates or metal hydrogen carbonates, that is metals with HCO3 group, decompose to give metal carbonates, water vapor and carbon dioxide. Here the sodium bicarbonate also decomposes, as it was not decomposing in case of carbonates and hydroxides, but the bicarbonate of sodium also decomposes. So sodium bicarbonate on heating forms sodium carbonate, water and carbon dioxide. Calcium bicarbonate on heating forms calcium carbonate, water and carbon dioxide. Magnesium bicarbonate on heating forms magnesium carbonate, water and carbon dioxide. The nitrates of potassium and sodium on heating melt and decompose to give metal nitrite and oxygen. Potassium nitrate on heating forms potassium nitrite and oxygen. The nitrates of calcium, magnesium, aluminium, zinc, iron, lead and copper, they decompose on heating to form the metal oxide, nitrogen dioxide and oxygen. Calcium nitrate forms calcium oxide plus nitrogen dioxide plus oxygen. Zinc nitrate forms zinc oxide, nitrogen dioxide and oxygen. Lead nitrate forms lead oxide, nitrogen dioxide and oxygen. Copper nitrate forms copper oxide, nitrogen dioxide and oxygen. The nitrates of mercury and silver, they form metal, nitrogen dioxide and oxygen. Silver nitrate forms silver, nitrogen dioxide and oxygen. Now the digestion of food by our body is also an example of decomposition reaction. The starch present in the food we eat, it decomposes into glucose and sugar. Proteins that we eat undergo decomposition to form amino acids. Fats and oil are decomposed to fatty acids and finally oxidized by the respiration into carbon dioxide and water. For example, starch in the presence of enzymes, it changes to glucose, and glucose on oxidation, that is respiration, it forms carbon dioxide, water and energy. Now how we can perform some decomposition reactions? Take some lead nitrate crystals in a test tube and heat them. The crystals first melt and on further heating give out both nitrogen dioxide, a reddish brown gas and oxygen. A yellow solid lead monoxide is left behind in the test tube. 2 PbNO3 twice gives 2 PbO plus 4 NO2 plus O2. Put some zinc carbonate in a test tube, fitting with a cork and a bent glass tube. On heating, carbon dioxide is given out, which will turn the lime water milky. The residue, that is zinc oxide, is yellow when hot, but it turns white on cooling. ZnCO3 gives ZnO plus CO2. Heat the orange color ammonium dichromate in a test tube. Upon heating, it swells and decomposes with flashes of light, evolving nitrogen and water vapor and a green solid chromium oxide. NH4 twice Cr2O7 gives Cr2O3 plus 4H2O plus N2. When hydrated copper sulfate is heated in a test tube, the blue colored crystals change into white anhydrous salt. The change may be represented by the equation CuSO4 into 5H2O gives CuSO4 plus 5H2O. However, anhydrous copper sulfate may be changed to the blue hydrated form by taking a sample of the anhydrous salt and adding a few drops of water to this. This is the test to detect the presence of water. CuSO4 plus 5H2O gives CuSO4 into 5H2O. So far, most of the reactions that we have considered proceed quite definitely in a certain direction, and it is possible to identify the reactants and the products. However, there also exists a group of reactions in which the direction of chemical change can be reversed by changing the conditions under which the reaction is taking place. Such reactions are called reversible reactions. Thus, the change of hydrated copper sulfate to anhydrous copper sulfate is a reversible reaction. And the equation is as given below, as given in the figure. To show this, the reaction is reversible, we put the sign in between the reactants and the products. If steam is passed over red hot iron, the latter is partially converted into magnetic oxide and hydrogen is released. If on the other hand hydrogen is passed over the heated oxide, it partially changes back to steam. So 3Fe plus 4H2O forms Fe3O4 plus 4H2. In either cases, the reaction ends with a mixture of reactant and the product. Thank you.